Good morning, mathematicians. Time for more spectral sequences, as has been the case of late. Yeah. Just gotta wait for this live stream to appear. And I think we'll go back to Vibel today. Time for more I think I've been forgetting to like my own videos. Primero. Sí, señor. First in chat. Okay, let's open up Vibel, I guess. Can't stay for long, but hello anyways. Well, glad you're joining us anyways, Arad. Even if for a time. Hopefully, life's going good. Hello, Kostaka Corey. So, yeah. What do I want to go read up on? What do I want to go read up on? Universal coefficient theorems, a la Vibel, maybe. Homological dimension. Should we jump into spectral sequences? Or should we go over to group homology and cohomology and try and see some spectral sequence applications? Maybe let's do that. Let's jump over there. Do I want to do a conversation episode? You're thinking of trying to get some podcasty people for videos on your channel? I would absolutely love to. Yes. Yeah. Normally I do my emails. I think in the description of this video should be my email. I've been using the email K-theory tutoring for this channel. So yeah, we can set that's a good place to reach me for planning a conversation. Yeah, I'd love to have a chat about stuff. Yeah, let's jump over 195. 195. Another math subject you're an infant in. Maybe one day you'll be an infinite in the subject. Yeah, mathematicians should be ranking themselves by ordinal numbers. And, Big Chad super goats should be getting the infinite ones. But then I guess there's, open questions, undecidable propositions when we get into real rankings. G modules are probably different than G modules. Yeah, I think what you saw in the table of contents, I think the lowercase g is really a math frac g. And it's supposed to be modules over a Lie algebra. So basically a representation of Lie algebras. Yeah. Mathematicians tier list video coming up. I've thought about doing it. Maybe we'll see. Lev Landau had a logarithmic rating system of physicists. Oh, interesting. Let's see. Okay, I don't want to get too distracted before we start doing some spectral sequence stuff, but I am gonna at least put this in a tab. A physicist ranked 1 was considered to have made contributions 10 times greater than a physicist ranked a 2. Oh, wait, so lower number is better? Humorous. Newton was a 0. Okay. I see. Oh, I see. It's right to the exponents. Wow. Crazy. I like it. You get back to your sushi? That's important. Reading some probability theory right now. You actually don't know if there's much overlap between cohomology. I mean, my guess is no, but I did, someone did on a live stream point me to a document about someone's thesis about cohomology theory and statistics. So there's something to be said, apparently. Okay. Inflation and restriction maps. Boom, boom, boom. Fit into a filtration of this, right? Spectral sequence codifying the relationship is Hochschild-Serre, right? Okay. All right, so this is just the setup, and I guess now we'll try to understand the actual proof. I suppose, in better detail. Likelihood of cohomology getting you rich. Oh, maybe. Well, actually, I mean, okay, I don't know. This is very indirect, but I was giving a talk about cohomology for the number theory group at my university. And I did see that there's an interesting application of cohomology in the case of elliptic curves. Basically, yeah, inflation's hitting everything, they say, even the math books. But in short, you basically want to find generators. You want an effective version, like a computable version, of finding generators for your elliptic curve. And, there's like this Hasse principle that allows you to solve, if you have like a non-degenerate, or does it even have to be non-degenerate? If you have a quadratic form, over the rationals, then it has solutions in the rationals if and only if it has solutions in all the p-adics, including the reals. And there's some sort of similar thing that you can do for elliptic curves, except not always. And there's this group, it's the Tate-Shafarevich group of your elliptic curve. And basically, it's like some kernel. It's like some kernel of some localization map from some Galois. You look at like the Galois group acting on the elliptic curve, but then you'll take the map induced at overall the local fields, basically, and you look at the kernel of this map, and basically so this is defined using cohomology. Anyways, what does this have to do with earning money? This is my vague way of trying to connect it to earning money, because something elliptic curve cryptography. Okay, so that's maybe one avenue for getting rich with cohomology. Once seen differential geometry in math finance? Oh, yes, definitely there's differential geometry in math finance. Yeah, so I guess maybe there could be Durham cohomology or something, believably. AH maps from H to A, the opposite now? Well, hold on, Desa. I haven't even read that part yet. You're ahead of me. Isn't it Eric Weinstein's whole thing? What's his whole thing? Or you mean differential geometry in physics? No, there's definitely differential geometry in finance. 100% there's differential geometry in finance. He's not. There's a lot of things that Eric Weinstein's wrong about. It's not about that. This is too early. Come back later. Sure. Is that acrylic Shaw? Yeah, I think so. Yeah. No expert either, but he talks a lot about spaces being curved. Yeah. It's just he happens, and he says totally correct things about that as well. It's just he also happens to have some theories of physics that people aren't interested in. Although here's a wild thing. Oh, I don't even know. I don't even know if I can bring up the tweet, but Edward Frenkel weirdly came out supporting Eric Weinstein, which is like, what? Edward Frenkel. Yeah. I don't know. Maybe this guy, maybe he posts a lot. So, where? Yeah, I don't know if I can find the post. Yeah, maybe he posts a lot. No, he doesn't post a ton, so it should be soon. It should be somewhere here. Yeah, I can attest. Yeah, this is kind of crazy. Look at this. I can attest that Eric Weinstein is a brilliant mathematical physicist. I recently did a deep dive into his geometric unity theory, and I think it has the potential to unify all forces of nature in a beautiful and novel way. Right? Like, is Frenkel falling off or what? I mean, this is so surprising, right? Yeah. So, yeah, it's a shame that the community has not properly engaged with it for so many years, but this is about to change. I mean, like, does Frenkel know about Nguyen's paper that, allegedly proves that the things, the mathematical ideas in Weinstein's paper are impossible? Of course. How else do you get to rich? I can't get rich hacking my own account. And also, nobody who knows anything about the subject takes him seriously. Yeah. Well, not about physics, anyways. I mean, obviously the dude's made money in finance, and he did his PhD under Bott, so he certainly doesn't know nothing about geometry. Theories of physics people aren't interested in are a dime a dozen. Yeah, fair enough. You read the Weinstein paper when it came out. You just see him as a former PhD student who has some grandeur delusions. His geometry being right or not, it's not even attempting to do quantization. Yeah, I've heard similar critiques. Yeah, obviously some great critiques coming from Sean Carroll. What does Frenkel know? He's a mathematician. / half serious. Yeah, I mean he's done mathematical physics, right? That's kind of where he got his start, isn't it? In his book Love and Math, he was very supportive of string theory. Well, that's neither here nor there. In my opinion. You've studied it. You studied geometric unity. Well, this is supposed to be a spectral sequence live stream. I don't know. Maybe this is quickly turning into a regular office hour as well. But yeah, Love and Math is a great book. There's a channel focused on GU, now closed, which had an anonymous contributor who expressed GU in terms of advanced Langlands-like math. Well, probably not. That sounds like nonsense then. Unless maybe that was Edward Frenkel. Maybe Edward Frenkel's been slipping, and that was him. I don't know. I don't see why there would be any point to get the Langlands program involved in any of geometric unity, other than some vague connections. Yeah, that's true. The more viewers I have, the more I can get derailed from chat. That's true. I mean, but most of my office hours have been casual office hours anyways. And to be honest, I kind of like the casual office hours. Those are that's sort of the normal state, and doing the spectral sequence learning is kind of an aberration. So yeah, I don't know. It's not the end of the world, but maybe I should. I have been thinking as I take this channel more seriously, like maybe there could even be other streams. There could be like the casual office hour stream, and then there could be like the math learning stream, and I could split them up into shorter things. I don't know. Apparently he has his PhD in the math. Who? Eric Weinstein? Yeah, he studied under Bott. Anything I would include in a LaTeX showcase document for a job application that requires one? What? A LaTeX showcase document? What is a LaTeX showcase document? You're showcasing your research? Surely they're not asking you to showcase your LaTeX skills. That's insane. What kind of job? Hom or Hom got an educated take. You only know the NLab distinction, but you don't think that's universal. Well, I do think it makes sense for people for whom it matters to... Yeah, you mean distinguishing them between when your category is like enriched in itself or something? I mean, yeah, I think, generally speaking, I think it's a good idea, but I've largely been ignorant of this. I just write Hom out of habit. I don't have strong opinions about it, but I mean, if and when it became more important to me to be careful about the distinctions about internal versus external Homs, then yeah. But I don't even know which one's which. Well, lowercase is just set Hom, is just external Hom, and then uppercase Hom is when it's enriched, I'm guessing. I don't even remember. You wondered if it was Frenkel. Did you really? It was just using the language of stacks. Well, stacks doesn't necessarily, like, that's totally independent of Langlands. Like, sure, Langlands uses stacks, but I also don't know. I mean, okay, I don't know a ton about GU, but I don't know. Actually, I guess the language of stacks makes a lot of sense. Could make a lot of sense for GU, right? Yeah, to express the bundles and mappings of GU. I guess that does make sense, because, isn't it about, he's trying to argue that, like, there's some, like, I don't know, certain kind of bundle, and there's some sort of special metric that comes out of it. So, yeah, I could see you, like, you're looking at the stack of all bundles on some space, and then you're trying to prove that there's like a unique one or universal one or something. I mean, I'm totally guessing, but show AG to AG is isomorphic, then Gmod is semi-simple. What? If you're saying if the map from coinvariance to fixed points is an isomorphism, then the category is semi-simple? Okay, maybe we'll do this. Maybe this is a regular office hour after all. If Langlands gets involved with physics, we could deceive physicists into counting curves as string theory people did. I mean, there already are some intersections, right? Like there already is some crossover. I mean, that is what Frenkel's doing, right? Frenkel's already living at some sort of intersection of stuff. Yeah, I think on the Not Even Wrong blog, there's also posts about things that come up at the intersection of these fields. They want like a demonstration of typesetting. What? For what job? It's a U of C position? Oh. For what job? Oh. For typesetting? Oh. Are you applying for the job that I used to do? Doing for the editing for the journal there. Yeah. Wait, what was your question about? Anything I would include in a LaTeX showcase document? I mean, I don't know. I guess you don't want to lie, right? So just, I don't know. Just say all this. Just make a bunch of things that you know how to make. I don't know. Look at all your homework and stuff, and I don't know. Just write some random nonsense that showcases things you know how to do. Yeah, I'm not sure. Yeah, I mean, for me, I'd pull out all the stops and make fancy diagrams and tables. I don't know. Why they do want a demonstration of typesetting? Oh yeah, typesetting job. Yeah, you're quite aware of G's problems as a quantum theory. Nonetheless, the theory has interesting concepts that have not been engaged with. Hom is simply metrosexual, huh? Wow. Leo, you look too young to even know the word metrosexual. But maybe you're closer to my age than I thought. Langlands is a buzzword. If you're using groups, you could say it's using Langlands language. Yeah, but then you'd be wrong. Weinstein's gauge coinvariant torsion and his specific analogy between Einstein field equations and Chern-Simons. Yeah, I don't know. Maybe, yeah. I don't know enough to comment. You had a flatmate once who wrote a Runge-Cutter differential equation solver in raw LaTeX. Nice. That's crazy. In raw LaTeX? Because I know like when I was doing my master's, I wrote a bunch of code for my relevant to my master's thesis. And one of the things, it didn't end up in my final thesis, but something I was playing around with is there's a way that you can have Sage and LaTeX talk to each other so that each time you compile the document, it runs the Sage code. You can put like Sage code in the tech document and it will run it. And it will like spit out, and you can have it run in such a way that it, spits out the output in the tech document, which is pretty cool because then you can send someone the raw tech file, and then they can like change the numerical values in there, and then read the PDF with it. So I don't know, pretty neat. What about H, MathCal H and MathBBH to distinguish cohomology groups and cohomology sheaves? Yeah, I don't know hyper cohomology. Yeah, I guess that all makes a ton of sense to me, and I do it all the time. Although sometimes I would say I abuse it. I play fast and loose, at least in my notes. I think in my most recent preprint, I was like a little careful about these things. R gamma for hypercohomology should be standard by now. Yeah, that's more Reading than a bold H, though, isn't it? Who's got time for that? Something to do with the calculus courses? Oh, is it that? Right, there's that job. I saw that job posting. Yeah. Oh, yeah. I guess they just want to make sure you have basic tech skills, so maybe you don't have to pull out all the stops. Peter Voigt, yeah, he's the not even wrong blog guy. Typeset, some nice looking calculus thing. Yeah, exactly. Would R-I or R gamma? Yeah. You are 79. Wow. Tell us your skincare routine. You doing crazy VO2 max training and saunas or what? How you staying so young looking, Leo? You mean solving numerical differential equations, all the numerics of it, via definitions in LaTeX itself, evaluated upon compiling. That is wild. Wow. Turing completeness will be the end of us. I mean, yeah. If the light switch on your bedroom isn't Turing complete, you aren't doing it right. Ooh, called out. It's okay, you pulled out the stops anyways. Well, that's good, right? You may as well show that you're overqualified for whatever menial teching that's going to be involved in this job. Mostly cocaine. Wait, what was that? What was that in response to? Okay. Anywho, let's take a look at this. I think we're well past office hours, we're in too deep into the nonsense to be doing spectral sequences. An official. That's your skincare routine. I see. Anywho, let me pull in my squeaky chair here, and let's see if we can solve this problem. So. What do we have here? So AG is the co-invariance. Wait, so what is we have a map going this way? But shouldn't it be really, it's more naturally viewed the other way, right? We have AG into A, and then we have A quotient out, what is it? A minus G dot A. Thanks for reading chat so much, but you won't abut many spectral sequences. Yeah, that's true. Okay, maybe tomorrow I'll be more of a hard ass tomorrow or something. I wrote it wrong. What is this, a plus? You wrote it wrong. I see. Yeah, this is a minus. It's a minus, right? It's a minus. Is it a minus? Right. Yes, because this has to be the kernel, so it's a minus. Yeah. Yeah. So exactly. You technically you didn't write it wrong. Yeah. Okay. So if this map is an isomorphism, then G is semi-simple. Or G, the category of G modules is semi-simple. Okay. Well, I'm sure that there's, yeah. So here's the trouble. Well, maybe this isn't a problem. But I'm just thinking about the fact that I'm sure that there's some fancy theorems or tricks I could use to prove semi-simplicity. Hello, Locke. And I'm not recalling any of those right now. So, we might just have to power through it. What can we do? I mean, we could take an arbitrary module, right? I want to show that this splits. I guess maybe what could I do? I could show that every short exact sequence splits, right? So maybe I could show that every short exact sequence splits. So maybe what do I need to do there? I could just do that by producing a section, right? I could just produce a section. There is indeed a trick by choosing the right A. What do you mean the right A? Oh, by choosing the right module. I see. Well, probably by the right A, you mean choosing ZG, right? Because really, this is an equivalence of ZG mod. And so, what? If we can show something about this ring, if this ring is semi-simple or something, what are we splitting? A short exact sequence. Yeah, let's see, semi-simple algebra. Which I should not have to look up this definition. We just did a Galois cohomology series and talked about the Broward group recently, but yeah, probably we can show something. The Jacobson radical of an algebra over a field is the ideal consisting of all elements that annihilate every simple left module. Blah, blah, blah. If the algebra is finite dimensional, are we assuming G is a finite group? A finite dimensional algebra is then semi-simple if its radical contains only the zero element. Right. So let's look at the ideal consisting of all those elements. Well, this is non-commutative. Right. Okay. So let's look at the Jacobson radical. Now, G is arbitrary? So our algebra is not going to be finite dimensional. Our algebra is not going to be finite dimensional. Everything on this page is about finite dimensional. If G is finite, and the characteristic, what do you mean? The characteristic, what do you mean? The characteristic? The characteristic of what? The group algebra? Then it is always semi-simple? The characteristic of what? Are you saying that for any commutative ring, RG is semi-simple if the characteristic? Okay, but what's K? Where are you getting a field from here? UG is KG mod? I don't think that's true. ZG mod, G mod, right? G modules is equivalent to the category of modules over the ring ZG. That's true. But Well, yeah. I mean, wasn't your question about G modules? Where was your question? Your question was about G modules, right? Where is it? Yeah, you just said Gmod. So we would be working over KGmod? Oh. Uh well then, but what does this have to do? Wait, but then what does that even have to do? I mean, KG, like you said, KGmod. I mean, KGmod is semi-simple if and only if the characteristic of K does not divide the order of G. So what does this have to do? But what does this have to do with this isomorphism? And like, because this is a statement about G modules, so how do we turn this into a statement about KG mod? Can anyone here tell you how you should view locally convex vector spaces? These guys are currently destroying you in a large deviations course. I don't even know what are deviations. Well, I'm more on the algebra side of things as opposed to the analysis side of things. So, I mean, Rn should be locally compact or locally convex vector spaces, right? So, maybe that should be your basic model. Well, it's also semi-simple if G is compact. Wait, that's... Huh? What is... That's not true. All finite groups are compact. But not all finite groups satisfy this condition. You need continuous representation? Well, for what topology? No, Leo, you weren't very clear. You sent me on a goose chase. You sent me on a total goose chase. That's okay. You still have you still have blue gear privileges for now. And then working over RC. Okay, well you gotta figure out what your question gotta sort out your question and come back. Locally convex vector space. Hey, wasn't there something else I had opened in a tab that I was gonna check out later? Something that Nikolai mentioned. Didn't I have it open in a tab? Where did it go? Oh, did I delete it? Oh, it was the Lev Landau rating. Right. That's what it was. Okay. Locally convex vector space. Yeah, I mean, I think like a lot of things in analysis or functional analysis, we're always just trying to generalize things. We're trying to weaken conditions, trying to weaken things that hold in Rn and see what we can still get out of it. Well, we got there. We're at Lie groups. Now say... Well, the proof, if you recall, is rather general. Well, you gotta, like I said, Leo, you gotta sort out what the actual question is and come back with it. Locally convex vector spaces, the generalized norm spaces, the topological vector spaces generated by balanced absorbent convex sets. Alternatively, they can be Right. A vector space with a family of semi-norms. My master's my master's my master's functional analysis course is coming back to me now. Although in general, such spaces are not necessarily normable, the existence of a convex local base for the zero vector is strong enough for Hahn-Banach theorem to hold. What's this? Something about the niceness of our balls? No, Hahn-Banach. Right, man, I forget all of this stuff. How could I forget? This is like, one of the theorems. One of the theorems of all time. Right. Bounded linear functionals on a subspace allows us to extend it to the whole space, right? Yeah, I remember. I mean, this is like the workhorse of functional analysis. You heard me, Leo. Actually, something I've never really learned properly is Frechet spaces and Frechet manifolds, because there's like infinite dimensional manifold. I remember once when I was young, probably it's not so bad to consider such things, but I remember when I was young dreaming of, you take a manifold and then you take its tangent bundle. And then you take its tangent bundle. And I thought, like, oh, what happens if we take the limit? What is it? The inverse limit, I guess. What is that? But I vaguely recall, isn't this the trivial bundle or something? Am I wrong? No, I must be crazy. That's not true. I thought I remember something about they eventually die or something. Maybe not. I mean, there's no real reason to consider this, but I was just dreaming, and I was like, well, what if we take... Because there should be some infinite dimensional manifold, right? And then I remember I got to something about Frechet spaces, and then I was too young at the time to handle it, and I just gave up dreaming about it. Definition via semi-norms. Yeah, let's see. Do we have some examples and non-examples here? Why would they die? I don't know. I just vaguely recall I thought something about the bundle trivializes at some point, but maybe I'm crazy. Iterated tangent bundle trivializes. Yeah, I don't know. No, I'm just hallucinating. I guess. You've been skimming through some representation theory textbooks, and why is everything finite groups? I do trivialize, Leo, but only locally. Don't you dare say I'm globally trivial. I localize trivially, as we all do. I'm just like you. Am I thinking about the contractibility of S infinity? I'm not, but now I am. Contractibility of S. Or maybe you were asking if I was... I see, when I was confusing those statements. Maybe. Yeah. Why is everything finite? So first off, I mean, there's plenty of representation theory textbooks that are not finite groups. There's plenty of things that are not finite groups. But, of course, finite groups is what we understand the most, right? This is the most, understandable part of representation theory. We can get a handle on it, right? It's the most, it's very computable, well, I guess not all the categories of representations we're interested in, as we've talked about, are semi-simple. But, Yeah. But trivializes, you mean, has some type of Cartesian product? Sort of. I mean, well, we were just, talking. Well, for when it comes to vector bundles, right? I mean, what's the definition of a vector bundle? You have some. It's a triple where pi is some. I don't know. We could just say topological. So let's say a continuous surjective map where, even let's just talk about a fiber bundle. What's a fiber bundle? So that for all points in the base space, there exists some open set containing B, such that, and I mean, I guess we need, because we want like compatibility conditions on this map. So we also want to give a name. So, and there's some isomorphism, homeomorphism from U cross the fiber. So sometimes we fix an F as well to say that the fibers are uniform, but whatever. There should be a homeomorphism here, right? So what that means, right? What that means is just a vector bundle locally looks like a Cartesian product. So on small scales, it's a Cartesian product, right? So if you think about the Mobius band as a vector bundle, or as a fiber bundle with fiber the unit interval over S1, then it's globally it's all twisted. But if you look at a small enough patch, you look at the fiber over this patch. I mean, it's just it's just a square. So it just looks like the Cartesian product of and what's this neighborhood? It's also an interval, right? So locally, it just looks like this Cartesian product. So vector bundles are locally trivial. That's what I meant. Now you mean special K is stupid and dumb? You're just trying to get you're trying to see how far you can push it before you get that gear removed, Leo. Factoring groups is hard. What do you mean by factoring groups? You don't have enough tools to approach any group order? Huh? Most textbooks seem to be said for first-year grad students. Well, first off, I don't know. You should almost just entirely ignore what a textbook says about who it's for. Like there's a million GTM books that like you could easily read at any point in your undergrad. Maybe not easily, but yeah. You don't have the brain cells to handle that? You do have the brain cells to handle it, Leo. I guarantee you. Even though the start feels simple, but you're not going to gaslight yourself. Well, yeah. Well, if the start feels simple, then just start at the start and keep pushing. And there's a lot of different representation theory books out there at a variety of different levels. So, I did see your live stream. Hey, I liked your live stream. I didn't show up, but I liked it afterwards. You recommend to go to Twitch? Yeah, I've been thinking. I don't know. It's just there's so much. I've thought about going to Twitch as well, but it's just so much work. It's just easier for me to set up live streams here on YouTube, because then I'd probably post my live streams to YouTube anyways. This is like more work for myself. Like, would there be a big advantage to me to going to Twitch? Maybe. One thing I've thought about is if I become more of a sellout, then I do some like linear algebra and calculus courses for engineers. But everyone's doing that, so I don't know. Maybe I should just do group theory. Stick with my niche market. What do I mean? A vector bundle is not Defined a locally free OX module. I do want to make videos about that. I do want to make videos one day about. Well, people have been harassing me about K theory. So the other day I started thinking about making a video about some basic about like the very first few pages of Karubi's textbook. But then I was thinking about the gluability of vector bundles, and then I was like, well, maybe I should just go make a video about the gluability of sheaves first. I don't know. You don't feel like Twitch is the place for educational type stuff? Have you guys ever actually learned anything from my streams though, or are you just entertained by math yapping? They're like 20 plus Twitch streamers, math streamers. And how are they doing? I don't know. Yeah. How are they doing? Is it worth it for me to do the extra work? I don't know. Can we use fiber bundles to define a product topology? Well, it's kind of backwards. It's more like you use product topologies to... I wouldn't even say you do that, right? I mean, fiber bundles are a generalized product, right? It's like you could think of, and I think someone on stream not too long ago sort of talked about. I think Arad actually maybe mentioned why you should think of semi-direct products as some sort of like twisted fiber bundle, or as like a fiber bundle or something. I think there's some way to make that interpretation literal. But it's a similar thing here, like a semi-direct product of groups is some sort of generalization of a product, right? And same thing here, like it's just a more general way. It's some sort of twisty version of a product. Your sushi is done. Hope it was good. You've uploaded your second interview. Okay, cool. I'll probably go check that out. I did listen to your first one, your post Faustian measures or whatever it was called. ASLM, I don't know what that is. What would I want to speak of? That was a good question. I don't know. I don't know. I mean, normally I spend like an hour every morning yapping about random bullshit. So I don't know. We could yap about random bullshit. We could talk about, my research, or you could try and explain more of this arithmetic hierarchy stuff to me. I don't know. There's lots of things. We could hash it out over email. Okay, I've got to go soon. American Sign Language. It's a company that makes machines, and TSMC uses NVIDIA. If I listen to that podcast, will I figure out how to get a 6-figure job doing math in that area? Well, you don't have brain cells, but you believe in Locke. Yeah, me too. What's the Silo theorem of rep theory? Probably that actually a student of mine in my directed reading sort of my mentorship thing I'm doing with some students reminded me of this theorem that says that the degree for every irreducible representation, the degree divides the... well, no, I guess this is more Lagrange's theorem. It tells you that the degree divides the index of the center. But I guess this isn't a converse theorem. So I guess Lagrange... I guess the analog of the Silo theorem would be some converse theorem about constructing... I wonder if that even exists. I wonder if that's true. Wow, that's such an interesting question. Presumably someone's proved it. Because right now I'm working on something that involves groups whose... it's more special than this, but partly it's groups whose The degrees of all of their ereps are at most dimension 2. So there's probably something about that in there. But that's an interesting question. That's an interesting question. Building representations of a given degree. I'm gonna look that up. I'm gonna be looking that up afterwards. How to groups that have representations, groups that have irreducible representations of a given degree. Fascinating question. Obviously, a vector bundle is defined as a projective module. For a while, you thought my name was Keith. The name of my channel, well, the name of my channel is wordplay on my name, which is Kristaps. Yeah, but it's not Keith. I guess I could be a Keith in another universe. That wouldn't be the craziest name to give me. Your favorite mathematicians nowadays are K-theorists. Well, I'm not a K-theorist, though. What book rep would one recommend for someone with approximately 5 brain cells? One book instead of jumping around. Well, actually, recently, so one of the books that one of these students was talking with me about, they've been reading through Steinberg's book. So maybe go check out Steinberg's book on representations of finite groups. I am a generalized product, yeah. But are fiber bundles a fibered product? Probably. I don't know. They should be, right? I mean, they should be. Right? Maybe not. But they're a fibration. Which is what? Maybe is a fibration like a fibered product in a homotopy category or something? You started learning spectral sequences along with me. Well, sorry that I've stalled out in the last couple days. You had to learn them before, but the streams made you say, okay, do it right this time. Oh yeah, maybe we should go look at Vecto, actually. Speaking of bundles, have I heard about Dirichlet unit theorem? Of course. But I've never analogized that to bundles. Bye! And you'd say just some of my life story? Yeah, I'm happy to yap about that. And mass shit talking, sure. Yeah, higher shit posting. Infinity shit posting. Infinity 1 shit posting. The name of your channel is also subtle wordplay on your name. Yeah. Okay, I gotta take off. Yeah. Thanks for joining me. And who knows what we'll do tomorrow? Maybe spectral sequences, or maybe we'll just yap about random crap. Anyways,